Welcome. In this video, we are diving into aggregation functions in DBMS. These are powerful SQL tools that let us perform calculations on a group of values and return a single result. Think of them like built-in tools to summarize data, very useful for data analysis and reporting. The most common aggregate functions are count, sum, average, min, and max. Throughout this video, we will look at the syntax and examples for each one so you understand how to use them in real SQL queries. Importance of aggregates in SQL. Aggregate functions are essential when working with large data sets. Instead of analyzing every row individually, aggregates help you summarize trends. For instance, you can calculate total sales, average salaries, or the maximum score in a class. These are extremely useful in business reporting and dashboards. They often work hand in hand with SQL classes like group by and having, which we will cover in later slide. Count, definition and syntax. The count function tells us how many rows exist for a given condition. Let's perfect when you want to count how many items or people are in a dataset. The syntax is simple. Select count in brackets column name from table name semicolon. If you want to count all rows, use count in bracket asterisk symbol. This is a good starting point for basic analysis like counting employees or products. Count example. Let's look at an example. Suppose we want to count how many employees are in our company. We had write select count in bracket asterisk symbol from employees semicolon. This returns the total number of rows in the employees table, giving us a quick count of all records. This is incredibly useful for summary report or dashboards. Sum, definition and syntax. The sum function adds up all values in a numeric column. It's commonly used for totals like total sales, total salaries, or total quantity sold. The syntax is select sum in bracket column name from table name semicolon. This is especially helpful in financial or sales related applications. Sum example. Here is an example. Select sum in bracket salary from employees semicolon. This will add up all the salary values and returns the total salary paid to all employees. It helps management understand payroll costs or budget requirements at a glance. Average, definition and syntax. The average function calculates the average value of a numeric column. This is useful when you want to determine things like average salary, average age, or average marks. The syntax is select average in bracket column name from table name semicolon. It is an easy way to understand the central tendency of your data. Average function example. Example time. Select average in bracket salary from employees semicolon. This calculates the average salary of all employees. Great for benchmarking or determining if someone is above or below the company average. Minimum function definition and syntax. Minimum function returns the smallest value in a column. It is often used when you want to know the smallest lowest price, minimum age, or the earliest date. Syntax. Select min in bracket column name from table name semicolon. This helps identify the lower bounds in your data. Minimum function example. For example, select minimum in bracket salary from employees. This gives you the lowest salary in your company. It can help in detecting outliers or validating compensation structures. Maximum function definition and syntax. Maximum function works the opposite way. It gives you the highest value in the column. Perfect for finding the most expensive item, the oldest person, or the largest transaction. Syntax: select max in bracket column name from table name semicolon. Max function example. Let's see an example. Select max in bracket salary from employees semicolon. This tells us who earns the most in the company. It is a quick way to spot top performers or highest value recorder. Combining aggregates. Now let's combine multiple aggregate functions. You are not limited to using just one. You can write a query like select count in bracket star, comma, average in bracket salary from employees semicolon. This returns both the total number of employees and the average salary in one query. Combining aggregates give a more comprehensive view of your data. Group by with aggregates. Sometimes you want aggregates per category. That is where group by comes in. It lets you group data based on column and apply aggregates to each group by example. Let's say you want to see the average salary in each department. You had write select department comma average in bracket salary from employees group by department semicolon. Now SQL will return average salaries per department, very useful for managers and HR teams. Having class with aggregates. Now you might want to filter groups. That is where having comes in. It works like where, but for groups. For instance, to find departments with more than 5 employees, you use having after group by. Having example select department comma count from employees group by department having count greater than 5 semicolon. This returns only the departments with more than 5 employees. This is useful for targeting large teams or analyzing performance in big departments. Aggregate functions in subqueries. Aggregate functions can also be used in subqueries. For example, select name from employees where salary greater than open the bracket, select average in bracket salary from employees close bracket semicolon. This returns the names of employees who earn more than the company's average salary. Subqueries like this add powerful filtering capabilities. Practical use cases. Aggregate functions are everywhere. Dashboards, reports, business intelligence tools. You will use them to calculate total sales, average customer ratings, highest revenue, and more. They are critical in decision making and performance monitoring. Summary of aggregate functions. Let's summarize. We covered 5 key aggregate functions: count, sum, average, min, and max. These functions help summarize large data sets. When used with group by, having, and subqueries, they provide deep insights from raw data. Understanding these is crucial for anyone working with databases or data analysis.